Okay, so today we continue on redox, second lesson. Okay, this time round is redox in terms of electron transfer. Okay, today we have seen oxygen and hydrogen. Now we move on to electron transfer. Okay, and relate to redox. So to recap, okay, please remember okay, how you define oxidation and reduction based on electron transfer. Okay, oxidation is loss of electron. Okay, so oxidation means losing electron, whereas reduction is gain of electron. Okay, reduction is gain of electron, and you can have a shorthand notation to memorize this. That is oiric. Okay, so when it comes to electron, oxidation is loss of electron. Reduction is gain of electron. So when you relate redox and electron transfer, you can memorize oiric. Okay, oxidation is lost electron, reduction is gain electron. Okay, now let's look at this example. Okay, I have sodium react with chlorine to form sodium chloride. First thing first, write down the chemical equation. Okay, the chemical equation. Sodium, the formula for sodium is Na. I write down. React with chlorine. Okay, chlorine is Cl. And to be correct, chlorine is a diatomic molecule, so we have to write Cl2, and then it forms sodium chloride. The formula of sodium chloride is NaCl. And as usual, I'm going to balance my equation. 2 here to make up the 2 chlorine, and then 2 Na. Okay, to balance the Na. Okay, now, how do you know who has gained electron, who has lost electron in this reaction? Now, you need to write the ionic equation, but not really the full ion equation. Okay, you only write the ions. Write down the ions for the compound. Okay, so first thing first, this Na, I'm not going to do anything with Na. Right? Then this chlorine, I'm not going to do anything with it because both of them are elements. Okay? So elements are atom, they are not they are not ion. They are either atom or molecule. So they will not be ion. So just ignore them first. But then in NaCl, it is a compound, right? Okay, so previously when we do about ionic equation, I told you, hey, if you are a compound, then actually the substance inside, they have a charge. This is actually an Na plus, and this is a Cl minus. Yeah, so when they got together, the charges cancel off, plus minus cancel off, so they become NaCl. Okay, now, so what happened is, at the very beginning, look at this reaction, at the very beginning, Na has got no charge. Na has got no charge, but after the reaction, it has become Na plus. Alright, so write this down. On the other hand, my chlorine, you can ignore the 2 first. Just ignore the 2. Ignore the 2. Okay, chlorine at first have no charge. After the reaction, it has become Cl minus. Okay, you have become Cl minus. You write this down. So this is what happened during the reaction. Na go from Na to Na plus. Cl go from Cl to Cl minus. So now you ask yourself a question. If Na suddenly become positive, is it because you have gained electron? No. If I gain electron, I should be negative. Am I right? So Na did not gain electron, because if it gain electron, it should be negative. So if it did not gain electron, it actually means that it loses electron. So now I know this one actually lose electron. Whereas when I look at my chlorine, hey, it goes from Cl to Cl minus. It becomes negative already, right? That's because it has gained electron. It has gained electron. So gain electron, that's why become negative lor. So now who undergoes oxidation and who undergoes reduction? Very simple. You have the answer already. Na to Na plus, you lose electron. You lose electron. So lose electron is oxidation. So Na undergoes oxidation. Okay? Whereas your chlorine undergoes reduction. Chlorine undergoes reduction. Okay, that's the idea. So that's the idea, all right? Okay. Now, sometimes the question will ask you to write the half equation for oxidation and also the half equation for reduction. Now, this is how you write, just that you have to complete it with electron. So you have to add some electron in this equation. Very simple only. Always put electron at the side of the equation which is more positive. So now you see, before arrow, I got Na. After arrow, I have Na plus. So which side is more positive? This side, right? So put electron here. If the charge goes from 0, this one nothing, to 1. So the difference in charge is 1, right? You put 1 electron. Okay, if you go from Na to Na2 plus, then you should put 2 electrons, something like that. Okay, next. Chlorine on the left-hand side. Cl minus on the right-hand side. Now, which side is more positive? I don't see any positive, but I know this one is negative. So this one negative means this one on my left-hand side is more positive. So I put electron this side. Okay? Then, don't forget chlorine is diatomic, so I have to write back 2. Each chlorine just now give 1 electron. So 2 chlorine give 2 electron and form 2 chloride ion. So you are done writing the half equation. Okay, so in this direction, what can I see? Na, sodium go from Na to Na plus. Okay, because this side is more positive, so I put the electron here. And when I put electron here, I know it means losing electron, so it undergoes oxidation. Chlorine becomes Cl minus. So because I put the electron on the left-hand side, it means gain electron. Gain electron means you undergo reduction. Okay? All right? Okay, now we're going to look at the second example. So there you go. Okay, all right. So this second example is about magnesium reacting with copper 2 sulfate. Okay, so I will write down the relationship between redox and electron transfer first. Is oil-rig. Oxidation is lose electron. Reduction is gain electron. All right, okay, I'll write down this for my reference. Okay, now, this is a reaction between magnesium and copper 2 sulfate. So I write the equation, Mg plus copper sulfate, CuSO4. Okay, so how do I complete the reaction? Very easy. Mg is more reactive than Cu. So Mg will kick out Cu and steal the SO4. So now I get MgSO4. Cu being a less reactive metal, then magnesium will be kicked out and it stay alone. Alright, so this is how I write my equation. So as usual, if I want to know the charges, what I do, okay, I look at them one by one. Mg is an element, so don't do anything. Next, copper sulfate is a compound, so I try to split it into ions. This is a Cu2 plus and SO4 is a 2 minus. So of course you actually have to memorize your ECS, so you know the ions and their charges, okay? Whereas MgSO4 is actually Mg2 plus SO4 2 minus. And lastly, my Cu here being an element, just don't care, okay? Element just don't care, don't do anything. There's no changes. There's no charges on it. Okay, so now let's look at my Mg first. Okay, let's look at my Mg. Okay, now before the experiment, I have Mg. After the experiment, it has become Mg2 plus. Okay, so this time round, when I write the half equation, do I put my electron on left-hand side or right-hand side? Wait, electron must put at the positive side. Okay, so electron put here. Right-hand side. Because this side positive, this side not positive. And is one electron enough? No. Because here no charge, that become 2 plus. So the difference from nothing to 2 electrons. Okay? Alright. So when I draw like this, I write electron now on my right hand side. Does that mean gain or lose electron? Gain or lose electron? It's a part of your product. Product is lose. Right on the right hand side means you lose electron. So this one, Mg, lose electron. So lose electron means what? Oxidation means lose electron. So lose electron means oxidation. So this Mg become Mg2 plus 2E is actually the half equation for oxidation. Okay? Right. Next, look at my Cu. It goes from Cu2 plus, right? Okay? Then look at the Cu after the arrow. Hey, it's just Cu without any charge. Okay, now this time around, how do I complete the equation? My electron, I have to write at left. That means before arrow or after arrow. Okay, it should be before arrow. Because the before arrow side, it has more positive. Okay, so I put here, electron. Is one electron enough? Okay, I bet you know already the answer. One electron is not enough. Because here is 2 plus, and here, nothing, 0. So 2 and 0, the difference is 2. So I'm going to make 2 electrons here. Right. So here, brother, you see, my Cu2 plus 2, it means Cu2 plus gain electron, right? It gain electron, right? It gain electron. So since Cu2 plus gain electron, okay, it gain electron, so that means it undergoes reduction. So this is the half equation for reduction. Okay? Right? Okay, so this is how you analyze redox reaction in terms of electron transfer. Okay, so after I give you 2 examples, the previous one and this one, I bet you have a better idea on how you analyze redox in terms of electron transfer. So now we are going to write this down in an essay form. If exam asks me, hey, how are you going to explain that this reaction is a redox reaction based on electron transfer? So how am I going to answer it? It's very simple. So here I can see Mg undergo oxidation, right? Mg undergo oxidation. So I will say, oh, magnesium undergoes oxidation. Alright? So in the exam, just write in full words here. Magnesium. Alright? Mg undergoes oxidation. Okay, why? Because the magnesium atom, okay, must have the word atom. Magnesium atom loses 2 electrons. Okay? On the other hand, okay, who undergoes reduction? Okay, the CuSO4, right? Okay, so you can write the copper 2 ion, or you can write a copper 2 sulfate undergoes reduction. Okay, because why? The copper 2 ion gain. Okay, it gain, is it, plus 2e, 2 electrons to become copper atom. Okay, I'm done. Alright, so this is how you explain a 4-mark question. Very simple. Now, additional question. Do you still remember what is OA and what is RA from our previous lesson? Yes. Okay, if you don't remember, here's a recap. OA means oxidizing agent. Okay, so how do you define oxidizing agent again? Itself undergo reduction. Okay, then Ra means reducing agent. Okay, so a reducing agent itself undergo oxidation. So now, my question, Mg undergoes oxidation. Mg undergoes oxidation. So since Mg undergoes oxidation, it is oxidizing agent or reducing agent? Okay, yes, it undergoes oxidation, so it is a reducing agent. Okay, then the copper sulfate or the copper 2 ion, they undergo reduction. So it is, undergo reduction means you are oxidizing agent. Alright, okay, so that's all for today's lesson about redox in terms of electron transfer. So I hope you learned something, and if you have any question, okay, please don't hesitate to ask. Alright, thank you so much.